Hey guys, welcome back to our show. I hope you're all doing well. I hope you're all doing really great. We're going to dive into the latest story that we've spotted in the AI world. Without further ado, Will, let's fire into it.
Let's do it. I mean, there's two stories technically, but they are linked. They are linked. It's two model releases from two different companies, and they're very distinctly different for two reasons. So let's launch in with one. I'll launch in with the one from Switzerland, which is a country I bet you didn't think would join the AI race, but it has. Let me share screen.
I'm not surprised, if I'm honest. I'm not surprised.
Are you not?
I mean, there's a bit of there's a lot of innovation happening there. There's a bit of crypto stuff going on there and what have you. So it doesn't massively surprise me. And they're quite it doesn't surprise me.
Do you know what? You know more than I do, to be fair, because it took me by surprise when I saw the name Switzerland. It's not something I normally associate with tech massively, so you're more in the know than I am. Well, they have. They've joined the AI race by releasing their own open source AI, which is very cool. It's called Apertus, and it is an alternative to proprietary models like OpenAI's ChatGPT or Anthropic's Claude, which is probably, if you're a first-time viewer, you'll be familiar with those two. And yeah, they've made it completely open weight. It comes in two sizes, 70 billion parameters or 8 billion parameters, so a small one and a medium large one. And it's comparable to the 2024 Llama 3 model released by Meta in terms of initial benchmarks, which I would say isn't anything to write home about, particularly. I mean, it's not that frontier, if you ask me. I mean, it's going back a year now almost between Llama 3. Why
are they doing it then, Will?
This is the interesting twist on it. They, in Switzerland, I don't know if you can see this paragraph here, maybe you won't, but you should be able to see it in the recording later. The model was built to adhere to the European Union's copyright laws and voluntary AI code of practice, which some US-based companies have reluctantly signed while claiming that the regulations will curb innovation and deployment. Apertus' training data was restricted to public sources only while adhering to AI crawler opt-out requests on certain websites. So, they have chosen to build a model adhering totally to what the European Union have tried to put in place with American companies. And this, you can think of what you will, but essentially it stops people. It has several key components to it, but the one that it references here is the copyright component, where it restricts what you can crawl and what data you can use, which is quite pertinent because obviously we had a conversation go back. I can't remember what day it was. Last week. It was last week.
It was last week.
Which we spoke about AI and copyright. So it's interesting. My initial knee-jerk reaction releasing that press release and looking at some of the benchmarks is that it has indeed stunted the output of what this model can be. You read the comments, though, of this article, and people are also commenting, yeah, it's not that good, but I'm glad that we're adhering to copyright laws. It's a very interesting one. I mean, maybe we are seeing with the European Union them choosing to curb the development of AI, and I don't know if that's a good thing or not.
It's interesting, isn't it? Because there's also, I guess if you think about, I've got two questions in my mind. Actually, I'll ask the first, which is 8 billion or 70 billion parameters. So for the audience, how small is 8 billion compared to other models?
8 billion is small. I mean, that's on the low end of something useful at this time. I mean, that's improving month to month. An 8 billion parameter model 18 months ago is vastly worse than an 8 billion parameter model today. It's worth noting that you still need a decent computer to run that. I mean, for example, I have a MacBook Pro. It's just up from the base MacBook Pro, so it's not the base one, but it's just up from it, and it's able to run a 7-8 billion parameter model at a reasonable speed. You can think of it, a rough layman's term, as if you are a little bit techie, you'll know that your computer has RAM in it, random access memory, and it's a good rule of thumb to compare how much RAM you have to the size of the model that you can run. So if you have a 4 gigabyte of RAM, then you can run a 4 billion parameter model. If you have 8 gig of RAM, you can run an 8 billion parameter model, and so on and so forth. It's not one-to-one, but it's a good rule of thumb to roughly assume what you can and can't run.
Interesting. That's really helpful. Yeah, thanks, Will.
So I know that you use a MacBook Air, so you can with 8 GB of RAM, so you could probably run this open weight model, but it is at the top end of your RAM, so it means it'll likely run slowly. You'd want something less than 8 billion parameters, really.
So there's two other things that strike me with this. Is firstly, if this isn't going to be a particularly good model, because it's been restricted in terms of the data it's been able to use to train itself. Number one, who's going to use it, and what's the point?
It's a fantastic question. So, and it's hard to know without being in the minds of the company that made this, but they have released it open weight and open source, which is never a bad thing. And also, I don't want to rain on it and say that it's a bad model. It's not. It's up there with as a good model. It's just not pushing the boundaries of anything at the moment. Other than it being open weight and open source, it doesn't. And other than being open weight and open source, the biggest claim to fame is that it adheres to the European Union's copyright policy. But it's not a bad model. So it's just not particularly frontier. You can learn a lot, though. I admire any company that releases anything open source, because it then becomes the public domain and together you can innovate something. So it might just be a stepping stone towards that.
And is this potentially a future where we're going to see with more copyright restrictions, so AI models can only train on open access data? And if that is going to be the case moving forward, does it even matter? Because we've also got, is it called synthesized data, where actually synthetic data. So AI models can just sort of almost replicate data and train themselves on data that they create themselves. So I guess my question is, moving forward, if this is going to be something that is going to be clamped down in terms of copyright laws, does it even matter if synthesized data can be used?
Again, I think we're a long way away from reaching a verdict on copyright, let alone having the laws changed to adhere to it. There's a lot of people that don't see an issue with the copyright. That they don't see it as a copyright issue using the data in training. There's obviously other people that do. I personally think copyright laws will change slightly, but not all the way. I just don't see it as a copyright issue. I might be wrong, but it's going to take a long time.
Last time, didn't we? Yeah.
And it's going to take a long time to work its way through. It's going to take a long time to work its way through the system of debate.
Interesting.
Before any laws are changed. But indeed, a big answer to this is synthetic data. It's not particularly an answer to copyright issue. It's an answer to the fact that we're running out of data. I mean, we've used the internet to train these models, and we need more data. And synthetic data is obviously a great way to create unlimited data for training and retraining models. So there's lots of things being looked at other than just giving it more information that you can crawl from the internet, and that's quite exciting as well.
Awesome. Right, are we going to touch on the other story we wanted to? Because usually we just keep to one story, and we probably how we did for time. We got a bit of time.
8 minutes. I think we should talk about it, because this one is interesting, and it's from a company that I continually see innovating, which is a different story. So let me share my screen for this one. It's another model release, so at least it goes hand in hand. So this is Qwen3-Next, which is from the Qwen team, which it's amazing how much I think it's Alibaba. I'm pretty sure it's Alibaba behind Qwen. It's amazing what you think you know, and then as soon as you're on a recording,
let's know in the comments if anyone knows.
As soon as you're on a recording, then you're like, oh, is that right? Because you're fact checking yourself. But Qwen is becoming a rather large player anyway inside the AI world, specifically coding. They have continued to release open source, open weight models that are very, very good. And this is no different. This is the new Qwen3-Next, which again is really trying to move towards a super efficient model to train and super efficient model to run, for you. So this is a large mixture of experts model. And if you don't know what a mixture of experts model it is essentially you have a total parameter size, say that's 100 billion. And inside that large neural network, you have a number of experts baked in. And when you ask it a question, for example, how do I write this creative story, the input parameters direct the query to the right expert within the model, and it only activates a small subset of those parameters. So you might have 100 billion parameters, but you might only need 20 of them to actually get that answer. This allows for several benefits, one of them of which is obviously you don't need as many resources to run a 20 billion parameter model as you do a 100 billion parameter model, whilst at the same time maintaining the same intelligence because you've not had to train a giant neural network. And this is the way most frontier labs are going now, where you have mixture of experts model. It seems to be a very effective and decent architecture. So this is no different, apart from the fact that it is a tiny model, 80 billion parameters model. Well, it's not tiny, but it's small in terms of large language models, from frontier labs, and it only activates 3 billion parameters during inference. This means it has very good performance, whilst also being really small to run and to train as well. So a fascinating release. Again, amazing when it's open source. You can look at all their training data, you can look at all their weights, and they are very good models. Very good models. I've not got anything to say about them. So it's really good.
So I guess in my mind, are there two? There's probably more benefits, but question one is, one of the benefits going to be for the actual AI itself, in the sense of it's not having to use as many resources, i.e. as much electricity, because it's not having to ramp up the whole sort of system just to get the answer. Because we hear about the whole cost and huge expense in just pure energy that's required to run these open AI and all the rest of it. Is that one of the big benefits, that it's going to reduce, a user uses it and it's not going to be, it's like using, I guess, the analogy of, you got a V8 supercar, but you're only pootling around town and it shuts off 6 of the cylinders because it doesn't need all 8.
Yeah, exactly. I mean, that's a good analogy to have. That's exactly it. And you can see it from the benchmarks here. So this chart here shows exactly what we have here. So the red is the Qwen3-Next 80 billion parameter model. Next to it, the blue is the Qwen3 235 billion parameter model. So more than 2 times the size is the current Qwen3 model before Next came out. And the benchmarks speak for themselves. On some of these benchmarks, the Qwen3 80 billion parameter model is beating that of the larger 235 parameter model. And the ones that it loses on, it's very close. It's not far off beating it. It's beating the larger model on 3 of the 5 benchmarks, with a very close second for the other 2. And that speaks volumes, because a 235 billion parameter model is much, much bigger, much, much more expensive to run, much more expensive to train. So if you're getting comparable, if not better on the majority of the benchmarks out of an 80 billion parameter model, that is a huge efficiency gain. So yeah, that's essentially what it is. And again, this is a mixture of experts model. So when you're running a query through the 80 billion parameter model, you're not activating all 80 billion parameters. You're activating just 3 on average.
Interesting.
So very efficient.
Because I think, because again, this jumps out to me in terms of, I guess, in terms of AvaMind, our app. For those of you who don't know, we're Ava Technologies, and we're a studio that builds software and AI solutions for businesses, but also we have our own app, which is a public-facing AvaMind app. It's an AI therapeutic assistant, and I think the reason I'm bringing this up is we've talked about having Ava, AI therapeutic assistant, as having the capability of being flexible for the user, because one day you might feel down and you need a therapist, but actually your mood might change during the day, your requirements might change during the week. You may one day need a business coach, you may one day need a fitness coach, you may one day need just somebody to give you a bit of a G up, and you might want Gary V specialized in an AI model to tell you to again smash it or something, whatever it is. It's that flexibility, because we're humans. We're not just set. We're not just, this is how we. The app's built for essentially one particular use case, which is therapeutic assistance. But people are dynamic, and I think I've always wanted us to explore that ability to change with our moods. We're fluid, so I think that ability, I guess what I'm asking is, will this type of model enable that flexibility?
It will. It's an interesting architecture, and it's certainly one to look at. The mixture of experts model allows you to have an efficient model that also has the capabilities of something a lot larger. So it's more about the efficiency gains. However, that's not to say that you can't bake in. You'd have to train your own, right, with your own set of experts in there. But that's not to say that you couldn't. And if you could, then yes, you could have a model that routes different types of data input through to different experts for response. One of them might output therapeutic techniques, another one might output motivational speaking, so on and so forth. It's definitely an architecture to keep an eye on, because it also allows that intelligence to run on much smaller hardware, which is also something that we are actively researching, developing, working on too. So yeah, it's an interesting architecture all around for all of the reasons that you've mentioned.
Fantastic. And just to share with the audience, Will, why are we working on these micro models?
I think naturally, for me, that's where the future lies, for many reasons. One, hardware is going to take a while to catch up to running the very large models. It's just not feasible to take the Qwen 235 billion parameter model. That's huge. I mean, you're not going to have the hardware. The vast majority of people are not going to have the hardware to run that. And that's still on the sort of, it's large but smallish compared to some. Some of them are over 1 trillion parameters. GPT-4 was quoted to be over 1 trillion parameters. So that's one reason, is if you can work on smaller models, you can deploy this kind of technology to more people, which I think is really important. The second reason is privacy. This is a big one for me. This is a new frontier of data input. You're giving these models humongous amounts of input, some of it sensitive, some of it not. But people don't really understand where it's going. It's going to labs and databases across the globe. Now, you can be comfortable with that if you want to be, because we share a lot of data anyway. For me, it's slightly more personal using an AI. It's much more of a personal interaction, and I think that people should have the ability to run these unrestricted on their devices. Especially now you're hearing about stories like OpenAI can pull out your chat histories and use that as evidence in court and things like that. It starts to tread in a direction that I don't necessarily feel comfortable with. So privacy's and also a massive impact. Third of all, cost. If you can get a small model running, it's cost effective for you as a company, because you don't have to, because again, you spend a ton of money running these AI models, let alone training them. We haven't trained ChatGPT. I mean, that came at an enormous cost before they've even started running it for people. So across the entire stream of companies, it costs a lot of money to run these models. So again, if they can be smaller, it means they don't cost anything to run, because they run on consumer hardware, and the user burdens the cost. So it's got a good benefit there as well. There's so many reasons, more than I can talk about, but those are the big three hero ones, and I think it's interesting.
Mate, that's awesome. Listen, let's wrap it up. Listen, if you're still with us, thanks so much. Give us a like, subscribe, drop us a comment, let us know what you think. We'd love to hear from our community, and it doesn't cost anything just to like this video, so really appreciate it as we grow this channel. So we'll catch up with you next time, and we'll continue to bring the latest news and innovation in the AI space. Take care, guys.
Cheers.